Hello, everyone, and welcome to our presentation. My name is Janine Donnelly. I am the Manager of Webinars for IBM Systems Magazine, and I will be the moderator for today's event. Today's webinar, Reliable Data Protection for Your Applications and Databases on Linux on Z Systems, is sponsored by Innovation Data Processing. Today's featured speakers are Patrick Simmons and Ed Gilroy. Pat is the product manager for Innovation's FDR Upstream. He's been involved with Upstream since the product's inception and has been with Innovation for over 23 years. Ed is FDR Upstream Development Engineer. He's been in the technology sector for over 40 years and has been with Innovation for 21 years. Today you'll hear how FDR Upstream provides file-level support while also providing hot database support for Oracle, DB2, IBM Notes, in addition to Linux on Z Systems recovery ability. With our introductions complete, Pat, I'll go ahead and turn the presentation over to you.
Hello, good morning, good afternoon, good evening, welcome. Welcome everyone to Innovation's webinar on FDR Upstream and reliable data protection for your Linux on System Z applications and databases. Today we're going to be discussing Upstream and its architecture and capabilities. Over the next 45 minutes, 50 minutes or so, we will be exploring the ZOS storage server, clients, database support, and recovery. As Janine had mentioned, we will be recording this session, so you'll be able to access it later. And if you have questions, we'll be available at the end of the webinar. The goal is to provide an overview of the power and reliability of Upstream, and if more information is desired, we invite all to contact us for a more in-depth discussion. Today's speakers, Pat Fitzsimmons, I'm Product Manager of FDR Upstream. Back when the product was first introduced, 200 megabytes was a lot to back up. Our license metric was based upon 16 gigabytes, and geez, today you have bigger USB drives. And we're in the era of big data where petabytes and zettabytes are needed to be protected. Ed Gilroy, development engineer, has been with Innovation for over 20 years, and Ed in prior lives has worked as a software development engineer at XCOM and Legion. If you look at these two pictures, we're either in a witness protection program or the Hair Club for Men. Sorry, but our featured guest is not going to be available today, so you'll just have to deal with us. So who is Innovation? We're a privately held company founded in 1972. It produced the first ZOS data protection product with FDR, Fast Dump Restore, and over the next 4 decades produced a suite of products unique in the market. We're headquartered here in the Garden State of New Jersey. We have 4 European sales offices in the UK, France, Germany, and Netherlands, and distributors in Brazil, Japan, Australia, and the Pacific Rim. We are doing active ZOS development, and all development is done here in the U.S., and support is handled by the office representing your region. Here's the timeline of Innovation products. So 40 years of producing cost-effective, reasonably priced solutions. So in the left-hand portion, FDR was born in '72 along with IAM, and if you look at the upper right, we have the newest product to the team, Cloud VTB. Stay tuned for more details. So a variety of market segments uses the Innovation solutions, education, state and local government, healthcare, manufacturing, financial, services sector, and a growing segment of open systems and Linux on Z systems sites. We make a very concerted effort in aiding customers and often get comments and accolades of appreciation from customers. And here's just one example. Somebody was doing a DR test and commented, "You guys did a great job. Your entire team the other night, very responsive." I frequently describe our support as personalized tech support model, where you don't need to provide your customer number or wait on the phone to get a problem number. And unlike some companies, you can call us and we answer the phone. And don't have the progression from level 1 to level 2 to level 3 support. We're also very proactive with our follow-up to ensure that a reported issue has been resolved. And we use web meetings frequently to support and help introduce and educate our customers. So this is what we're going to be talking about today. This is our agenda: the Upstream overview, architecture, file level backup and recovery, database agent support, management, disaster recovery, and then a summary, and we'll do a Q&A at the end. The Upstream overview. So we use the power and systems of ZOS as it makes a great foundation for data protection and thereby upstream. ZOS mainframe, with its unmatched reliability, availability, and serviceability, and outstanding I/O bandwidth and tightly controlled and protected environments, make it an excellent platform for data protection. And if you're running Linux on Z systems on an IFL, then you might already be experiencing the financial benefits of running on ZOS mainframe with lower software licensing costs and lower total cost of ownership. By migrating your Windows applications to Z Linux, you can also save on environmentals, heating, cooling, and energy. ZOS is a closed operating system with very regimented development and testing that has evolved and been in service for over 40 years. Many of the newer developments in the open systems world has been solved in the mainframe arena. Security, LPARs, and virtualization would be a few. So what is FDR Upstream? The suite is a comprehensive and business resiliency solution that provides data protection, business continuance for servers and databases everywhere in the enterprise. What that is backup, data protection and backup. Upstream provides a flexible and scalable solution for securing anything from a single file server to the largest corporate data servers. It's a dual component system offering high performance, reliability, and automation. And then with a management layer, makes it a third component. It integrates with existing ZOS tape management, scheduling, and security systems. Upstream provides file-level backup, hot online database support, and system-level recovery. So the Upstream family of products are composed in two categories. The mainframe platforms, which are Linux on Z systems. And let me get this out of the way right now. I'm going to call it Linux on Z systems as long as I can, but I'm going to flex at some point to Z Linux and just Linux. I don't know how many times IBM can rename this one product. So it's Linux on Z systems as well as USS, ZOS Unix. So those are the mainframe clients. And in the open systems clients are Windows, AIX, Sun Spark, Sun x86, VMware, and x86 Linux. Any data that can be NFS mounted can be backed up and restored. So tooling around in the Upstream world. So there's graphical user interfaces, the Upstream Director, or the Upstream Web Portal. Then on the mainframe in TSO, there's an ISPF interface. It's used for product configuration, used to generate UST batch JCL production skeletons, provides interactive control and real-time monitoring functions, and then ZOS batch utilities, used for initiation of backups and restores, and run client processes. Allows easy automation of Upstream ZOS maintenance and utility. So in the Upstream universe, there's a choice of storage servers. There's FDR Upstream ZOS mainframe. It's been available for 23 years. And then the Upstream Reservoir, that's the newer addition to Upstream, and that supports Windows as the storage server, AIX, or Linux, x86 Linux, or Z Linux. The same client distributions are used for both storage servers, and tapes are compatible between the two different storage servers. Our focus for this call, though, is the ZOS mainframe storage server. Now, if you're interested and attracted to Linux 1, then you can still use an Upstream solution for data protection with any of the storage servers that are available. So the features of FDR Upstream ZOS storage server. It supports ZOS 1.13 and above, supports backups to ZOS disk and virtual and physical tape, migration utility to move backups from disk to tape, and then a vaulting utility to create secondary tape copies. Despite a rumor that tape is dead, it's not dead for everybody. Many shops still have and rely on physical tape drives. Upstream supports backups to disk and tape, and while virtual tape is very popular, not everyone has a VTL. So if you don't have a VTL, chances are you might only have a limited number of physical tape drives as well, so that might make sending backups to disk more appealing so you can meet your backup window. In that case, Upstream provides a migration utility to migrate disk data sets off the tape, with Upstream updating the Upstream catalog to point to tape. And you can do a single file restore directly from tape without having to recall that backup to disk first. Upstream also provides a vaulting utility for making secondary tape copies for off-site recovery. This can either be used for disaster recovery purposes or for long-term archival. With vaulting, it's a secondary tape copy with its tape known to Upstream, but the files aren't cataloged in the Upstream database. The last data set on the last tape of the tape set is written control information. So all you need to do is run a utility that copies that into the Upstream database, and it's pretty quick, and then that tape is then cataloged, and you can do any type of recovery. And if you do have a VTL, Upstream will just work fine. And we have worked with EMC Dell, and our Upstream products get excellent data dedupe results with the DLM and data domain. So let's talk a little bit about the features that Upstream provides. So Upstream protects file and system level data and applications while leveraging high-performance ZOS mainframe media. The engine of FDR Upstream storage server resides on the ZOS mainframe. It runs as a standard ZOS started task with multiple subtasks and is responsible for the storage, retention, and management of all Upstream backups. It is also where the main configuration control files reside, together with the Upstream database, and that tracks the location of all current backups. Various log and history files are also maintained here. Upstream interfaces with the existing ZOS mainframe systems and resources, such as the ZOS Tape Management System, RMAN, CA1, XARA, or TLMS, and then the ZOS Job Scheduling Systems, CA7, Tivoli TWS, or Control-M. Also works with the security systems and interfaces, RACF, ACF2, and Top Secret. Staff RAC calls allows Upstream with the ability to provide 3 levels of protection so you can control who gets access to the data. Upstream also works with IBM PassTicket. PassTicket is a security service that allows any authentication via the storage server to be done using auto-generated hidden password strings, PassTicket. Upstream also honors any local security, so if somebody does not have the local authority to write a file, they cannot restore it. For the client component resides on the system being protected. So, for example, Z-Linux is resident on ZVM or on an LPAR. Upstream supports the Z-Linux client either in FBA or CKD-defined disks. For ZOS, if it resides on the HFS or ZFS file system, it communicates with the ZOS storage server. And in both cases, USS and Z-Linux, it can communicate over hypersockets, a memory-to-memory transfer is very quick, and it does not need to traverse the production network for the backup data. If the client system is on a different CAC than the storage server, then they can communicate and connect over the OSA adapter. So as you can see, Upstream should just fit in nicely with how your data center has been running with the systems and resources for quite some time. So now we're going to talk about the Upstream architecture. We're using the client-server dual-component model, and we'll show you a few different common configurations. So at this point, I'm going to introduce my associate, Ed Gilroy, to go through each of these different configurations. Okay, so we've got 4 different configurations to go through today.
The first one is Linux on Z systems using hypersockets. That would be where your Z Linux system is on the same KEK as your ZOS storage server. Our second one is where you would be using the OS adapter, so you could be on the same KEK or on a different KEK. Our third configuration would be ZOS Unix or USS data over hypersockets. That again would be on the same KEK. And then our last configuration is ZOS Unix over OSA, so that could be on the same or different KEKs. So our first configuration, we start with the data, your user data. It's on the right-hand side. It's either on local disk to the Z Linux virtual machine, or it is NFS mounted. The upstream Z Linux client will read the data off the disk, format it for transmission, and send it through ZVM over hypersockets and into the ZOS LPAR that contains the FDR upstream storage server, and eventually land it on the backup media down at the bottom. We utilize the Web Portal and Director to provide you with management capabilities of this entire process, as well as backups that you've done previously. The next configuration is backing up the same Z Linux data, whether on local disk or on a mount point, NFS mount point. So it's the same configuration. The right hand is where the data is. It's read by the upstream Z Linux client, transmitted through ZVM, out over TCP/IP through the OS adapter, down in from the OS adapter to the LPAR running the storage server and onto the backup media. Same management systems are available in the OS adapter case. Our third configuration is backing up ZOS Unix data, or USS, over hypersockets. So in this example, we have two ZOS systems, both in the same KEK. The right-hand data is, again, your ZOS Unix data. However, it will either be on HFS or ZFS file systems or an NFS mount. That data will be read by the ZOS Unix client, transmitted through TCP/IP to hypersockets, and then down the other side into the FDR upstream storage server, LPAR, and then back down onto the storage media. The same management interfaces are used again, no matter what your configuration. And our last configuration is ZOS Unix data on HFS or ZFS or NFS mount. We'll read the data on ZOS Unix, transmit the data through TCP/IP. This time it'll go out over the OS adapter, down into the upstream storage server, LPAR, and then finally onto the backup media. In this example, we also could have a ZOS Unix client running on the same LPAR as the upstream storage server to back up its local ZFS or HFS files. That's identical to the configuration we have here. And again, the same administrative interfaces are used.
So obviously, Ed, I think you'd probably want to go over hypersockets. What kind of performance have we seen over hypersockets?
So for file system backups, you generally see something on the order of 60 meg or greater per second. That's highly dependent on your environment and how many files there are to back up. If there's an extremely large number of small files, that performance can be degraded.
How do we gauge what is capable over a given network? Is there any kind of utilities that are available?
Yeah, so we have a built-in performance test capability that you can run either before you do your first backup or after you've gotten a baseline, and that will allow you to tune the system, make configuration changes to your OS adapter, your hypersockets configuration, select the right MTU, etc. And then we also have parameters in upstream itself that you can modify, but the performance tests are the way to do that.
Okay. File level backup and recovery. Upstream provides extensive support for client systems, including advanced Unix file systems. Specific features include hard links, symbolic links, security information for files and directories, support for platform-specific extended attributes. For example, USS supports tags, SE Linux, and support for the most popular file systems. Support for remote NFS mount points and CIFS shares. Upstream has a very simple file specification syntax. Backup syntax that is easy and understandable. Either // or /* selects all local volumes for any platform that's supported. So now we're going to talk about our synthetic backup technology, called the full merge backup. The foundation of upstream processing uses this technology that in today's distributed backup world is common, and it's called synthetic backup. In 1994, we added this full merge synthetic backup capability. You do a first-time full backup, then a series of incremental backups, and then when you would normally run another full, you run the upstream synthetic merge. So you do the first-time full, series of incremental backups, and then you run the synthetic merge. You submit the job, goes down to the client, sends a picture of the disk up to the storage server. He compares that with prior backups. Anything that he can't match, he'll request that list of mismatched files, sends that up to the storage server. At that point, he then merges the first-time full with the incrementals, accurately reflecting any deleted files or renamed files. When that process is complete, you have an exact image of the system at that point in time, but without having to send up the unchanged files. So it's a powerful facility. We'll go into greater detail in a little bit on this. And there are also a few different types of merges that help reduce tape copying. So unlike some other competing products that have a type of synthetic backup, this data reduction method optimizes backup and recovery. With this, you can restore files, directories, subdirectories. You can easily recover entire file servers or virtual machines and databases. File and directory recovery is simple, and you can restore to either the original location or to an alternate or entirely different machine. You can also recover entire machines, but that takes a little bit more consideration and careful planning and action. So Ed will now show us the flow of the merge.
Okay, so we're going to go through a hypothetical 2-week cycle of backups. Okay, so for week number 1, we start on the left-hand side of the diagram that's going to be animated here. In step number 1, we start with any type of upstream full backup. So when you're just getting started out, that would be what we call a first-time full. That backup will contain every file that currently exists on the server at the time of the backup. So to run a first-time full, you run the job, every single file is transmitted over the network. That's a requirement for the very first time. Subsequent to that, in step number 2, an incremental backup identifies the changed files and copies them onto the incremental backup data set. In this example above, files A, F, K, P, and R have been changed during the week on the Monday through Thursday days of the week, and they're placed on the full backup. They appear in this diagram in green. Step number 3, the full merge is specified by setting the backup configuration merge option to yes, and then the job is run. Server files changed since the last incremental backup are copied onto this full backup data set. You can think of this as collecting today's incremental data. These files are colored green in the diagram. Step number 4, the remaining server files are copied from the prior backup onto this full merge backup. These are the files that have not been changed during the week, so they are not transmitted over the network. This backup can now be used to restore any and all files from the single set of tapes that contain this new full merge. So that's week number 1. We start up week number 2 on Monday to Thursday, again doing incremental backups. In this example, B, G, L, N, and S are being changed and subsequently backed up on those dates. Step number 6, another full merge is run. Server files changed since the last incremental backup are copied onto this full merge data set. You can think of this again as today's incremental data. These files are again colored red. And then the remaining server files are copied from the prior full backup onto this full merge. This backup can now be used to restore any and all files from the single set of tapes that contain this new full merge. So at the end of this process, we now have 3 fulls, the original one, the one we created at the end of week 1, and the one we created at the end of week 2. You can restore from any of those fulls or any of the intervening incrementals, as long as you've retained the backup data sets they're on.
And this is the process flow that I just went through and but detailed in the slide, week 1 and week 2. Okay, let's take a break. An unusual couple of weeks with daylight savings time ending for us people here in the U.S. The Cubs winning the World Series for the first time in, 100 years? And then the election, which I'm not even going to talk about that. And we've covered some complex features, so man, we're beat. So let's take a mental vacation. Let's look here at the beauty of some of our national parks. First we're seeing Bryce Canyon. Boy, the National Park Service does a tremendous job of promoting this. The cost to enter is very reasonable. You can get in there for not a lot of money, spend a few days wandering around acres and acres of this natural beauty. You can see in Zion's is really a terrific place as well. And if once you hit 62, the National Park Service will sell you for $10 a lifetime pass to any U.S. national park. I mean, that's such a bargain. So enjoy what we have here in the U.S. with our national parks. Okay, let's get back to work. So before we get into the details of the database support we have, maybe we've not mentioned the affordability of Upstream yet, so we'll take a little commercial break here. Upstream is a very reasonably priced product. We don't have an a la carte type of menu. All the database agents are included, as well as the features and functions that we spoke about, are all included with the license fees. Backup, restore, disaster recovery, vaulting, reporting, management interfaces, all included. Upstream also comes with a file transfer facility with the ASCII to EBCDIC translation capabilities. So you really do get a lot for your money. Okay, enough for the commercial, back to work. Okay, so Upstream online hot database support. Innovation is a development partner with Oracle, supporting RMAN, works with IBM for DB2 and Notes. Through the partnership, we get access to database vendor-provided API to perform hot online backup. So an organization is able to back up and protect the database while it's still up and in production without taking it offline or down. So in this era of 24/7, this is essential. For Oracle, Upstream can operate as an Oracle Media Manager library product that allows it to be used with Oracle Recovery Manager. This is an overview of the support for the Oracle RMAN process, and we'll go through each step in turn. So Ed's going to take us through that.
Okay, for step number one, the Oracle RMAN configuration interface provided by the web portal dynamically constructs the supporting files and parameters. So if you use the web portal, you can get set up very quickly with one single screen in order to do RMAN backups. In step number two, the Oracle DBA constructs, alters their existing backup script that you're using to back up with RMAN. Upstream is defined in the system as an Oracle Media Manager. That's all taken care of by the web portal. The DBA also configures RMAN or Oracle and possibly cron to describe when the backups will run. They're generally client-initiated. The RMAN script is invoked. If there is an existing process to do this they already have in place, that will work just fine. Okay? So then in step number three, RMAN receives this request and it performs its normal processing. At this point, the number of RMAN configured channels is used to begin as many parallel connections through to the storage server as are configured. Each channel will record its data on its own media. So if you make a 4-channel backup, as in our example, you will end up with 4 output tape or disk files on the mainframe. So now we're at step 4. Once the request has begun processing, a pipe connection is made to the Upstream libobk.so RMAN interface module, and the Oracle backup data begins to flow. Step number 5, this module reformats and sends that data to the Upstream client running on the local Linux system. It also establishes a TCP/IP connection to the storage server and reformats and transmits the Oracle backup data. And in step number 6, the ZOS storage server receives this data as it's being transmitted, reformats it for storage, and places it on the backup media. At the appropriate time, it updates the Upstream database, the ZOS user catalogs, and tape management database to indicate the successful completion of the backup.
Okay, so Upstream also has a similar type of support for DB2. It has multi-channel support. It's a similar construct in that the DBA is really in control of the backup process, and Upstream is just the storage server. So this is the overview of how that DB2 support lays out. And this is the step-by-step detail. So management, you need ways to manage your backup processes. The data protection management and many system administration and operations can be accomplished using the Upstream interfaces, and we'll show them to you today. The Upstream interfaces are the Director, the Upstream Web Portal, and TSO ISPF. Using the client-server mode with dual-component description, the UPSTREAM Director and Web Portal might be thought of as a third tier as they communicate with the clients whose data is being backed up and protected and the storage service that is managing the backups. So this is an image of the Director. It's the management interface. It's a Windows-based graphical user interface, and it provides a directory tree of backups and files within a backup. It allows the administrators to perform ad hoc backups and restores, run jobs and generate reports, review the upstream logs, both the client logs as well as the ZOS logs, check the status of upstream operations, perform inquiries to see what was backed up, and more. It is not intended to be installed on every server being protected, as it is just the administrator's interface and tool. We find many upstream ZOS administrators will batch initiate their backups and then client drive file restores with the Director. The Web Portal is, as I mentioned earlier, a newer interface in the upstream environment. It uses an application server and external database and provides a single web-hosted environment that has the ability to monitor, control, and perform upstream actions against multiple storage servers. The coolest thing about it is automated client upgrades, and we'll get into that in a little bit. You're also able to edit client configurations, provide storage reporting based upon data protected, terabytes protected, number of files, and number of tapes. Administrative roles can be assigned, allowing restores for non-administrative personnel, and also provides Oracle RMAN configuration. You can easily switch between systems. For end users, no need to be aware of the wires and what's behind the scenes of a backup process. Besides providing web access, the Web Portal also has a set of data gathering tasks running that contact backup clients and storage servers to obtain stats, scan backup versions, collect data set information, history, and so on. It uses an Apache Tomcat application server, or WebSphere, with a Derby database that can become the foundation for the new web services provided. The next version of the portal will support MySQL, SQL Server, as well as Oracle. The Upstream Web Portal collects detailed information about the installed inventory of upstream clients, including the version, operating system platform, storage server it connects to, DNS or IP address, members of any groups, etc. The compilation of information provides a consistent dashboard view to the storage administrator for any of the upstream supported clients. So to round out our tour around the user interfaces, we're going to talk about the upstream ISPF interface. The upstream storage server includes a full set of ISPF panels, which provide status monitoring and batch initiation services. Among other things, can be used to create and initiate backups and restores. The backup and restore specifications are saved as JCL, which can then be submitted as standard ZOS batch jobs or optionally through a ZOS job scheduler. It's used for product configuration, used to generate UST batch JCL production skeletons, provides interactive control and real-time monitor functions, generate reports, operator modify command control interface, and also backup function management. So here's a look at a job. Ed, why don't you tell us about this job?
Okay, so this is a sample of a simple backup process that you would run. We'll see later there's a UST batch interface to the product, and this job is a typical UST batch job to do a backup. So we start off by specifying the JCL parameters, obviously, but then we get into what machine do we want to back up. In this case, we call it EFG SATA. The action we want to do is a backup. The backup profile that we want to use is called, just in this case, it happened to have the same name, EFG SATA. Then we tell it, the merge keyword says, what type of backup will this be? We then say what storage type we will be using, in this case tape. And then we have that simple backup specification that Pat mentioned earlier. /star means backup every file on this system. Every file that's on a locally attached drive, okay? That will not include NFS disks unless you tell it to. And then you end up with the simple end of job step stuff with /star. So that's a standard ZOS backup job to back up any Unix server. To do it right there, whether USS or Zlinux.
Okay, so we talked a little bit about the user interfaces. Let's show them to you right now. Okay, Vanna? So we're going to take a look at the interfaces. So the director, that's the Windows-based GUI. It has a series of tabs which represent the actions to be performed, a group of icons that are shortcuts for frequently accessed screens, and menu items. We click on that pizza box or the bullseye there, depending upon what you see. We have the target system list. This window displays all the client systems that are registered in the upstream environment. Among other things, it shows the IP address and port number, status of the upstream daemon or service, version of the upstream client, and operating system type. From this screen, you can also retrieve the client logs, run performance tests, and inquire on the activity. So is the upstream client up or down? Now let's look at the upstream status. The status window shows all the activity running on an upstream system, regardless of how it was initiated. So you can initiate a backup using your ZOS scheduler, an enterprise client scheduler, or perform ad hoc attended backup. From this window, you can kill, pause, resume, and monitor jobs. Next, we look at the profiles, and that brings you into an area that displays information about the systems being protected, including the type of backup, full, incremental, or the merge, media that the backup is stored on. In this case, it's 2 disks and mostly tape, and then the size and date of the backups. Let's look at the storage server list. For customers who have more than one upstream storage server, this window allows you to toggle between systems. Having multiple storage servers provides some flexibility, as you can be doing maintenance on one storage server while at the same time performing backups on others. Let's look at reporting, the host reports. Here we see several report types and a wealth of filters that allows you to customize reports to suit your needs. They include backup, history, host log, and tape history. After building your custom report, you can view the output in RViewer or export it to Excel. And you can also save the report criteria so you can easily load it in the future. Now we're gonna, let's live on the wild side. Let's do a restore. So to perform a restore, you simply select the system that was backed up, choose the backup version, select the directory or files to restore, set the target client system to go to. Optionally, you can specify an alternate location for the restored file. And finally, you click the Start Restore button. At this point, additional windows will launch, displaying messages and stats about the operation. Boom, restore complete. Now let's look at the other interface, the web portal. So again, the portal is a browser-based interface that is a supplement to be used with the director. Among the more interesting features of the portal are the client upgrade and end-user restore capability. Looking at the tabs along the top, we see the following: storage server security. This is where you define the upstream storage servers in your environment. The screen lists the IP address and port number, CPU ID name, upstream started task name, as well as the version of upstream. It will also provide information on the level of security that is enabled. And if multiple storage servers are defined and use the same security system, such as RACF or Top Secret, only one system needs to validate the login. An awesome reporting feature is the backup storage usage, and this provides information that displays tape and disk storage totals either for your entire upstream environment, a single storage server, or a single client system. Now let's take a quick look at this. So our entire total for all storage servers combined is 300 terabytes, and mostly it's on tape. If we drill down, we see in UST-CRIS a server that has backups to disk and tape. And on the lower left portion of the screen is total bytes, and lower right is total files. On another server, we see a different mixture of backup media and types. This provides very detailed information about the history of backups for this system. The client list shows all the clients in your environment, regardless of what storage server the data is stored on. It aggregates the information and displays the operating system, client platform, and version of the client software. While we're in the client list, we'll show you a more advanced feature, and that is to change the client configuration. Here, you're shown a dialog with common configuration options that can be changed. And for more advanced config options, you can click Advanced and manually edit the config file. You can also restart the client service or daemon from here. It's not unusual for the upstream administrator to be in a different location, building, state, country than ESA. So that's where this feature is very valuable. All right, now let's look at the client upgrade. And again, this is the most popular feature of it. It provides an easy and intuitive way to upgrade client systems from a centrally located user interface. You're able to select based upon a number of selection criteria. First, you get the new client distribution from us via electronic download, and you store it on your PC. Then you log into the portal, select Client Upgrade tab, click Upload Files button, and that selects the distribution file and transfers it up to the portal on the mainframe. You can then filter based upon client systems, installed versions, or groups that you have created. Then you select the client system, one or more, as you can multi-select. And then you add the clients by multi-selecting and then hitting Add. At that point, you hit Start the Upgrade. And then the new version that you've gotten from our distribution is upgraded. Pretty slick. Details of the upgrade process are then displayed, and if not successful, the client software is rolled back to the prior version automatically. Let's look at the Users tab. This is where all the users are defined. You can be an upstream administrator and user restore person. These users can validate using the storage server credentials like RACF, LDAP, or Active Directory. Here, you specify if the user has upstream administrative privileges or only restore capability. After a restore-only user is created, one or more client systems are then linked to that user, and only those systems are presented to the user when they log in. The Restore tab does exactly what the name implies, restores. The number of systems that are displayed is determined by which user is logged in. An administrative user will see all the systems aggregated. And to perform a restore, simply drill down to the file system to choose directories or files, and optionally you can restore to an alternate location. Okay, so we talked about backup and recovery, and now we need to talk about system recovery. Oh, ISPF. Take two. So we talked about backup and recovery. We're going to show you the ISPF panels. So this is available in the new version of Upstream 3.9.1 that's available today. So Ed's going to take us through a brief demo of the ISPF.
Okay, so there's just a few features here, and there's a lot of cross-similarity between this, the portal, and everything, but this is for ISPF users. So we'll go through, in this case, we'll go through status. You'll see here that there are at least 3 backup jobs running right now. If you continue to hit enter, you'll see that the rate at which they're backing up, how many bytes they've done, how many files have been done, how much CPU time they've consumed to date. So this is a view of the active things on the Upstream storage server. Okay, that's option number 2. We're going to skip over some of these definitional ones. You only do those once, so we'll come down to reporting, which is very similar to how it works on the web portal and on the director. Here we're going to say, I want to see all the backups for particular profiles that start with the name test and anything at the end, and we want to see a backup report. So you hit enter, and very quickly you see that there's one profile called test001. He has 6 backups. They've been variously lucky or not to run, and they've created various amounts of backup data when they ran. Okay? So these are all available to view for all your profiles. The next thing we're going to cover is the registered name table, or the registry. This is where you saw registered names in the web portal and the director. This is the same interface, only just from ZOS. Here we can see all the registered names to this particular started task that I had selected on the first menu. Here's their TCP IP addresses, their port number, and when the last time they accessed the system was, and what version is running at those remote sites. Very much the same information you see, again, with the web portal. Okay, and the last thing we're going to cover quickly is management. This is the one place where if you've got a ZOS-centric view of the world, you can come in here, very much like reporting. You say what you want to, what profiles you want to process, and the record types backup. You can now see all the backups that have run for this particular profile, when they were run, what the completion was, and you can also see what the MVS dataset names that were created are. Okay? These particular ones are in what we call date and time format, so they're stamped at the date and time the backup ran. You can also choose to do GDGs. We embed the profile name in the backup dataset name if you so select. There are a lot of options for naming your ZOS datasets. They're all described in the documentation. And that's pretty much an overview of the ZOS storage server. And the only thing I left out was this list at the bottom is all the active storage servers in your configuration.
Okay, so we talked about backup, file level backup, file level recovery, and now we need to talk about disaster recovery. And we'll breeze through this because we're running out of time. So I'm going to briefly go through this, and it's going to walk you through the rescuer process. So the goal of the rescuer is to reduce disaster recovery for Z-Linux to a single command intended strictly for Linux on System Z running under ZVM. A single job step for Z virtual machines. It provides a configuration detection utility that you execute just prior to a backup in every backup. And recovery is accomplished through a proxy machine. And the rescuer does the rest. So it's really one command. It's complicated. It does it uncovers, but it's just one thing that a user has to do. A recovery example, 1.4 gig of 76,000 files recovered in 6 minutes. The rescuer is 2 parts, the setup and then the rescue. You do the setup daily and the rescue only when you need to do the rescuer. And like I said, you run the rescuer setup once every day and it's quick. And this is the data that is captured, file system, sizes and types, mount points to file systems, LVM, file system config info, Linux swap config, boot information, write passwords for minidist and linkdist, and the information gotten from domains. Okay, so Ed's going to then take us through this process.
Okay, so to do a rescuer setup, again, this is, as Pat mentioned, the step that runs right before every backup you do every day. And its intent is to capture information about the Linux virtual machine and store it inside the backup so we can access that later at recovery time. So step number one, you prepare and customize a UST batch job to include the rescuer setup step. Once customized, submit this UST batch job to begin the rescuer setup process. UST batch job will contact the FDR upstream ZOS storage server. The storage server will then pass the rescuer setup command request to the upstream client software on the Linux system virtual machine. And then in step 4, the rescuer setup will begin to execute. This script file will run under the control of the Linux machine. Once that starts executing, one of the first things we do is try and contact if you've specified it during the configuration of the rescuer setup, we'll try and contact your DERMAINT product on your system and obtain a directory entry that will be helpful when it's time to recover. It makes it a little bit more transparent. And that is optional. Step number 6, the rescuer setup script will now build a file called dr_info. This file contains Linux-specific system configuration information that will be used at recovery time to reconstruct the Linux virtual machine. Once this information file has been built and saved to disk, and the elapsed time of this entire process here is a few seconds at most, status and return code information is returned via rescuer setup script to the upstream client, and then ultimately the client software passes this status information back to the ZOS started task/storage server, and the UST batch job that initiated the rescuer setup process will end. That UST batch job will have a return code set to indicate the success or failure of this entire process. A JCL return code processing feature can be used to determine if subsequent virtual machine backup job steps should be executed.
Okay, and this is a process flow of what I just went through. And this is going to be the restore flow process.
Okay, so if you want to rescue a virtual machine, okay, you've wiped it out, you've lost a disk, your array's gone bad, whatever. We do that through a proxy machine, a Linux proxy virtual machine. This is set up ahead of time, and it runs Linux, and it runs our rescuer process on there. So we'll go through this step by step, okay? The rescuer setup script will read and process the virtual machine's directory entry from the backup and attach the appropriate mini-disks and devices to support this recovery. So here we go. Step number 1, in order to use the rescuer, there's several prerequisites needed on the rescuer proxy virtual machine. The documentation outlines how to set all those things up. You then need to prepare and customize the UST batch JCL that will execute the rescuer. You can customize the rescuer command line as you desire after review of those options. Once the rescuer script begins to execute, and we're in step number 4 here now, it will map the ZVM via ZVM link or attach commands to the appropriate disks from the Linux virtual machine that you're trying to recover. It does this by reading the saved configuration from that USDR file we created and optionally the rescuer DERMAINT interface. In step number 5, the script will now create and format the logical volumes, partitions, and file systems on the matching devices attached in the prior step for the target virtual machine you're trying to recover. And then in step 6, the FCR upstream client is instructed to restore all the operating system and client files onto the disks attached and formatted in the prior steps. This is generally the longest running step of this process. In step number 7, the restored system is now made bootable and ready for reboot. And in step 8, the DAS devices that were previously attached, formatted, and restored to the proxy virtual machine are detached so that they can be accessed normally when the rescued virtual machine logs on. In step 9, the rescued target ZVM virtual machine is ready to be logged on via whatever your standard methods are. The script does not actually perform this step since there are many methods by which you might accomplish this. In step 10, the rescuer script ends and the upstream client returns the status of the script execution to the initiating UST batch job. And the UST batch job ends in step 11 with an appropriate ZOS return code indicating the final status of the script execution. You can now log on your rescued Linux virtual machine.
Success. Recovery. And that's the detail of what I just went through. So, continuing the conversation, thanks for taking the time. Here's our contact information. I know we're running a little late. Here's some resources that are available. Our web page, client user guides, ZOS user guides, our concepts and facilities guides. We offer a free no obligation trial, or we can do a web meeting. And this is information about our corporate offices. So as we hope you can see, Upstream should fit just nicely in with how your data center has been running with the systems and resources for quite some time. In summary, the product is reasonably priced based upon strictly the terabyte capacity to be protected, and fees include all the features that we discussed. We offer to meet and discuss with you and your team via web meeting, and also offer a free no obligation trial to test the products in your environment. So please don't hesitate to reach out to us or to your local innovation office with any questions. We're grateful for your interest, and thank you everyone for attending today.